Okay, hi everybody. My name is Cristina Palmero. I'm a research fellow at King's College London, and I work on social intelligence systems, which means creating and building robots and virtual agents that can understand what we do, and so that they can react and adapt to what we do in an appropriate way, right? But what we need for these intelligent systems to understand what we do is not only to detect it, but also to understand that we have individual differences, that the context in which we are, like the people with who we are interacting, influences what we do, and also the task, the shared environment, and so on. So a few years ago, with colleagues at University of Barcelona, we created this dataset, UDIVA dataset, which stands by understanding dyadic interactions with video and audio signals, which has around 100 hours of audiovisual recordings and transcripts of almost 200 non-acted dyadic face-to-face dyadic interaction sessions with around 150 participants, in which they could do different tasks, collaborative and competitive tasks. So, and we had information about sociodemographics, personality, mood, fatigue, relationship among the people, if they knew each other or not, task information. I mean, so much information. We recorded it with 8 egocentric and exocentric cameras, and we had 5 different tasks. So with this type of data, which is available, we did research on, for instance, personality recognition with social scientists and psychologists, but also behavior forecasting, behavior generation, among others. And now we are focusing on the Lego task, because imagine that we can wear like smart glasses, or we can have a robot that can try to either help us in the future doing some tasks, like specifically procedural tasks. So you can see here some examples of what this UDIVA-HHOI, which stands for Human-Human Object Interaction, contains. So the idea is to work towards improving this behavior understanding, considering both intra and interpersonal dynamics and all types of multimodal and contextual information during this procedural task. And what we saw is, of course, we can do many things. Like, for instance, we can give a brick to another person, but the way we give this brick can be done in many ways. We can pass the brick, we can place it next to the other person, and so on. So the context of the interaction changes the meaning of what we're doing. So we have collected annotations, very dense annotations of what people are doing. So we have nonverbal and verbal events for 28 of these annotations, which stands for around 15K events. So what we are recording is lots of information for each event, but most importantly, we have what people do, the semantic meaning. We also have the modifiers, like if people did things correctly or not, or they attempted to do something but they couldn't, or things that are incomplete. But we also have cause-effect chains. So I did something because the other person asked me to do something. And we have all of this densely annotated through 28 sessions. 21 of them are spotting, in the sense that we have frame annotations in which an event is happening. And for the other 7 sessions, we have exactly start and end timestamps, which gives us opportunities to do so many things. And right now, with this data, which is already publicly available, we are organizing a challenge at ECCV, European Conference in Computer Vision, and we have 5 different tasks, which are separated in. So we have 3 tasks separated into 5 tracks: multimodal, exocentric, and egocentric event recognition, event anticipation, and causal event grounding. And so the challenge is underway. The submission deadline is 12th of July. So I encourage you to participate if you want. We're also organizing a workshop called Contextus, which the goal of which is to emphasize the context, the importance of context. And you have the QR code here. And my poster is downstairs today, so feel free to drop by to know a bit more about the work that we're doing. Thank you so much.